Deno is a modern runtime for JavaScript and TypeScript that is built in Rust, and that makes it super fast. If you're familiar with Node.js, then you'll be right at home with Deno. It's very similar, but has some improvements over Node.js. In fact, the creator of Deno also created Node, and Deno is meant to be the successor to Node.js. Fun fact, Deno is an anagram. Rearrange the letters in Node to spell Deno. Deno has no package manager. It uses ES modules, has first class await, has built-in testing, and is somewhat browser compatible by providing built-in fetch and the global window object. Aside from that, it's also very secure. It's completely locked down by default and requires you to enable each access method specifically. This makes Deno pair nicely with MongoDB since it's also super secure by default. You'll need some basic TypeScript knowledge to get started with Deno because it does use TypeScript by default. You'll also need some basic MongoDB knowledge and understanding of RESTful APIs. Throughout this video, I'm going to be referencing some things that you might want to copy and paste. There is a written blog article and a GitHub repo with everything that you'll need. Just check the links in the description below. You'll need to install Deno to get started. If you're on Mac or Linux, open up your shell and use this command. If you're on Windows, then open up PowerShell and use this command. For this tutorial, we're going to use Oak, a middleware framework for Deno. This will provide routing for our various app endpoints to perform CRUD operations. So we'll start by creating a server.ts file, and then we're going to import the Oak application method. If this is the first time that you've used Deno in VS Code, you're going to want to install an extension. So we'll go over here to extensions, and let's search for Deno. And you'll see right here, Deno from Deno land. So this is an official extension. So go ahead and install that. And then let's open up our command palette and let's type in Deno initialize workspace configuration. And then enable Deno linting, sure. And enable unstable APIs, let's say no. All right, so now this should go away. Now, because it has TypeScript built in, it's letting us know that this is imported but never used. So let's go ahead and use it. So on the next one, we're going to create a new application and we'll use this one in just a minute. Now, if you're familiar with Node.js, you'll notice that Deno does things a bit differently. Instead of using a package.json file and downloading all of the packages into the project directory, Deno uses file paths or URLs to reference module imports. Modules do get downloaded and cached locally, but this is done globally on your system and not per project. This eliminates a lot of the bloat that is inherent from Node.js and its node modules folder. So let's finish this one out. We're going to add a port. So we'll say port 3000. And then we are going to have our app listen on that port. And then let's just console log server is listening and on what port it's listening on. All right, so let's save this file. And now we're going to create another file called routes.ts. So routes.ts. And this time we're going to import router from our Oak module. So let's go ahead and create our new router. And then after that, we're going to export our router. And we'll do some more stuff here in the middle. In just a minute, we'll come back to this. So let's go back to our server and let's go ahead and import our router. And then let's go ahead and before the listen, we're going to have the app use our router. So we're going to say app use router.routes. So this is going to implement the routes that we create. And then also router.allowed methods. So this is going to allow router HTTP methods. In most tutorials, you'll find that they use the Mongo third-party Deno module. For this tutorial, we're going to use the brand new MongoDB Atlas Data API to interact with our MongoDB Atlas database in Deno. The Data API doesn't require any drivers. So let's set up our MongoDB Atlas Data API. And you'll need a MongoDB Atlas account. If you already have one, sign in. If not, you can sign up for free. And from the MongoDB Atlas dashboard, on the left side, you'll now see Data API. Let's click on that. Now, by default, all MongoDB Atlas clusters have the Data API turned off. So let's go ahead and enable it. Now, after enabling the Data API, we'll need to create an API key. So let's go over here to API keys and then create API key. And you can name this whatever you want. I'm going to name mine Data API key and then generate API key. Now be sure to copy this API secret right now because you're not going to see it again. Also take note of your app ID. If we go over here to Data API, we'll see in our URL endpoint right here is our app ID. So I'm going to copy that as well. Now back to VS Code. At this point, we need to set up each function for each route. Now these will be responsible for creating, reading, updating, and deleting documents in our MongoDB database. So let's create a new folder. We're going to call this controllers. And then within that, we're going to create a new file and call this todos.ts. And next, we're going to set up some environmental variables to keep our secrets safe. So for this, we're going to use a module called .env. So we're going to import the config module from the .env module. And next, we'll use config to extract our data API key and our app ID. Now, these are going to be pulled from another file, which we're going to create now in our root. So we're going to call that .env, just the extension, no file name, .env. And within this, we're going to input some plain text, and basically in this format, our data API key, and then we'll put our key here, and then app ID, we'll put our app ID here. So I'm going to go ahead and paste those in. So again, this is a plain text file that allows us to store secrets that we don't want to be uploaded to GitHub or shown in our code. You won't be able to use my API key or app ID because I'll be deleting this test after I record this video. Now, if we're going to upload these to GitHub, we'll want to make sure that these are not uploaded as well. So we need one more file here. We're going to create a .getignore. And then within that, we'll just put .env. This will just tell Git to ignore this file so that it's not tracked. All right, so we can close those out. Now back to the todos.tx. Let's configure some variables that we'll use throughout each function. We're going to start out with a base URI. This is going to be the base of our endpoint that we're going to query. And in this, it's going to use our app ID. We'll also need a data source, which is going to be cluster 0 for me. That's the name of my cluster. And then for the database, I'm going to call mine TodoDB. And then for the collection, todos. And you can name these whatever you want. And then next, we'll define our fetch options, passing in our data API key. And now we can finally start creating our first route function. We're going to call this function add to-do. This function will add a new to-do item to our database collection. So this function will accept a request and a response. Again, this is TypeScript, so this might look a little different to you. Next, we have a try catch. And if the request doesn't have a body, then it's going to return an error. Otherwise, we'll get our to-do from the body. So we're going to request our body from our request and then extract the to-do from the body value. Next, we'll define our complete URI by using our base URI and then using the insert1 endpoint. And then we'll finish out our query here by using our collection database data source and then passing in our document, which is our to-do that we got out of our body. We'll set our options body equal to JSON stringify the query, and then we can pass our URI and our options into this fetch, which is going to be our data response, which we're going to await the JSON. And from that, we're going to get an inserted ID. If all goes well, we'll get that inserted ID back. We'll pass a response status of 201 and then pass the data that we receive back. And if we have any errors, then we'll catch that and process those errors. And then lastly, we're going to export this add to do so that we can use it in our routes. So let's do that next. Let's go back to our routes now and let's implement our first route. So let's go ahead and import our add to do from our controllers to-do.ts, and then we'll implement this first route. So this is going to be a post route. It's going to be at /API/todos, and we're going to execute the to-do function. So let's go ahead and test this route. We can open up our terminal and we're going to say Deno run server.ts. Now, like I mentioned before, Deno is locked down by default. So we have to specifically tell it that network access is okay by adding the --allow net flag. And also that read access to our project directory is okay so that it can read our environmental variables. And for that, we have the --allow read flag. So let's go ahead and run this. And we should see that our server is listening on port 3000. Now to test this, we could use Postman, Insomnia, or my favorite is Thunder Client. It's an extension in VS Code. So I'm just going to open up my Thunder Client over here, and we can start a new request here. And we're going to do localhost port 3000 /API/todos. And this is a post request. So let me get some of this out of the way so that we can see. And our body will include a JSON document that we want to add into our database. So we're going to pass this document, title, complete, and then the to-do ID. Now, normally I wouldn't create an ID manually. I would rely on the MongoDB generated object ID, but I didn't want to add another module to this project to convert the bsun object ID. I wanted to keep this tutorial as simple as possible. So let's send that, and it looks like it was successful. So we have success true, and it's returning us the data that we sent it, also the inserted ID. For now, let's move on to the read route. So we're going to start with a route that gets all of our to-dos called get to-dos. So that's going to be in our to-dos TS after our add to-do, and I'll paste that right here. So this is going to be get to-dos, and it has a response. Again, we're using the base URI, but this time we're using the find endpoint. In our query, we're not going to have a query body this time. We're just going to tell it the collection, the database, and the data source. Now we'll add to our options body, JSON stringify the query, and then get our data response from our fetch. And then we'll get all of our to-dos from our data response. Then if we have to-dos, we'll respond with a status of 200. And then in our body, we'll pass a success and our data that we received. If we don't have to-dos, then we'll pass a status of 500 and pass an error here. And of course, if we have some other error, we'll catch that and respond with that error message. So this should return all of the documents from our specified collection. Now, lastly, let's just go down here and let's go ahead and export our get to-dos as well. And then we'll save that and go back to our routes. And then we can add this into our routes as well. So we had our add. Let's also import our get to-dos. And then we'll also specify our next route. So it's going to be after this one, we'll say get. Let's just make this a little bit prettier here. So we have router.post, which we just tested earlier, and we just added our get, which is going to go to the same API, but it's using the get method. And that's going to execute our get to-dos function. So since we've made changes, we're going to need to restart our server using the same command as before. So let's open up our terminal, we'll press Ctrl+C to stop it, and then run the same command again. And now we should be able to test this new route. So in Thunder Client, instead of a post, this time we're going to use a get. Now we don't need anything in our body. So let's go ahead and send this. And let's see what we get. We get success true, and it returns the one document that we know is in there. If there were more documents, of course, they would show up here. All right, next, we're going to set up our function to read a single document. So we're going to call this one get to do. We'll put this right after our get to dos. So this one is get to do. This one is going to accept a params and a response. So our params is going to be our ID that we're looking for. With this, we're also going to have our base URI, and then we'll add to that our find one endpoint. And in our query, we'll have our collection, database, and data source as usual, but this time we're going to filter. We're going to add in our to-do ID, where we're going to parse int our params.id. So this is going to be the ID that we're going to pass to it through the URL. So then for our options body, we're going to stringify our query again. We'll fetch our data and then get our to-do. Now, if we have a to-do, we'll return it. If we don't, we'll return an error. So let's go ahead and export this as well. So this is get to-do. Save that, and then let's go over to our routes and let's import that. So that's going to be get to-do. And then we need to implement that route as well. And this is, again, is going to be a get, but this time it's going to be /API/todos/ID. So whatever ID we put here, that's what it's going to look for, and it's going to execute our get to do function. All right, so let's get rid of that semicolon that we didn't need there, and we should be good to go there. Now remember, again, since we made some changes, we're going to restart our server. All right, now we should be able to test it. Let's go over here. And this time we're going to do a get request, localhost 3000 API/todos. And this time we're going to look for the to-do with the ID of 1. So we see right here, to-do ID of 1. That's what we're looking for. So we should get back the same response as we did before because there's only 1 there. So to further test this, try adding more test documents using the post method and then run the 2 get methods again to see the results. All right, so next we're going to set up our update route, and this is going to allow us to make changes to existing documents. So we're going to call this one update to do. So again, we're in the to-dos TS file. we're going to add an update to do function. This is going to accept params, a request and a response. So we're going to get our ID that we want to update. And then the request is going to contain the data that we want to update. So in here, we're going to have a try catch. We're going to get our request body. And then from our request body, we're going to extract our title and our complete. Those are the items that we're going to update in our document. From this, we're going to get our base URI, and we're going to add to that our update one endpoint. And then in our query, we're going to have, again, our collection, our database, our data source. We're going to filter it to the specific ID that we want to update. And then this time we're going to pass an update. So in here, we're going to use our $set operator, and we're going to set the data that we want to update. So then we're going to stringify our query into our options body, run our fetch, and get our data. If everything works out, we'll respond with a 200 and then return what we received back. And if there are any other errors, we'll catch those and process those. Let's go ahead and add our update to do to our export. Save that. We'll go to our routes, and we need to import that as well. Update to do, and then let's add that route. So let's get rid of this semicolon here. And then this one is going to be a put method. So this is going to go to API/todos/ID, and then it's going to run our update to do. So let's save that. And then again, we need to restart our router, Control-C, run that again. And let's go over to Thunder Client. So this time we are still going to look for this todos/1. That's the one that we want to update. But this time in our body, we're going to tell it what exactly we want to update. So if we look at our previous response, the title was to-do-1 and complete was false. This time we're going to set the title again to-do-1, but we're going to change complete to true. And remember, this needs to be a put request. So let's go ahead and run that. And this time our response is going to indicate if a document was found or matched and if a modification was made. Here we can see that both are true. If we change this to a GET request, so let's get the document again. So now we can see the document was updated and complete is true. All right, next we're going to set up our delete route. So we're going to call this one delete to do. We'll put that here in our todos TS. So delete to do is going to accept params and a response. So params again is going to be the ID that we want to delete. So we're going to add on to our base URI the delete one endpoint. In our query, we have our collection, our database, and our data source again. And this time we're filtering it again to the to-do ID that we want to delete. In our options body, we're stringifying the query, we're running our fetch and getting our response back. If everything goes well, we'll have a status of 201 and we'll return what the response was. If there are any errors, we'll catch those and process them. Let's go ahead and export this as well. Save that and go to our routes, and we need to import that. And then let's also add our route. So that's going to go right here. We'll have our delete route. Again, it's going to be /API/todos and then the ID that we want to delete. But again, this is the delete method, and it's going to run our delete to do. So since we made changes, again, we're going to restart our server. And then we can go to Thunder Client. And this is a delete method. So we're going to delete the to-do with the ID of 1. So let's send that. Our response will indicate how many documents were deleted. In this case, we should see that 1 was deleted. So if we go to get, and we just get all, so just /todos, we should see that there are no documents returned because there's nothing in the collection anymore. And next, we're going to create one more bonus route. This one is going to demonstrate a basic aggregation pipeline using the MongoDB Atlas Data API. We're going to call this one get incomplete to-dos. So again, in our todos.ts, we're going to add that next, and that is get incomplete to-dos. And this is just going to have a response. For our URI, we're going to use our base URI and then add to that our aggregate endpoint. Now for this, we're going to have our aggregation pipeline. This is going to be a very basic aggregation pipeline. For this, we're going to use $match to find all of them where the complete is false. And then after that, we're going to use $count to count how many we have incomplete. In our query, we're going to have our data source, our database, our collection, and then we're going to pass in our pipeline. Again, in our options body, we're going to stringify our query, we're going to run our fetch, and then we're going to get our incomplete count. If we have an incomplete count, then we'll have a status of 200 and then respond with the incomplete count. If not, we'll respond with a 404 and pass an error message. All right, so let's go ahead and export this as well. And then in our routes, let's import it. This is a GET request. So I'm going to put it right here. So it's going to be a GET request at /API/todos/incomplete/count. And that's going to run our get incomplete to-dos function. Now, because we made updates, let's go ahead and restart our server again. And I went ahead and added some more to-dos to our database. So I just ran a get on our /todos, and here are all of our current documents. So we have to-do 1 is incomplete, to-do 2 is complete, to-do 3 is incomplete, to-do 4 is incomplete, and to-do 5 is complete. So this is going to run through and count how many are left incomplete. So to do this, remember our route was /todos/incomplete/count. So let's run that. So now we responded with how many are incomplete, and there are 3 incomplete. So we created a Deno server that uses the MongoDB Atlas Data API to create, read, update, and delete documents in our MongoDB database. We added a bonus route to demonstrate using an aggregation pipeline with the MongoDB Atlas Data API. So what next? Check out the complete code on GitHub linked in the description. You should be able to use this as a starter for your next project and modify it to meet your needs. Now, I'd like to hear your feedback or questions, so let's chat in the MongoDB community. Like this video to help us out and subscribe if you haven't already for more videos like this.